This is another topic in our applications of integrations unit. So it's going to be a lot like this chart where you compare normally graphically. Actually, these problems will always be graphic. F to F prime and F double prime, and you're talking about these vocab words, okay? But instead of given F, F prime, and F double prime, it's defined in a different way using integrals. So it's defined where these are problems where you're given a graph and you say, this is a graph of F, so you're going to be looking at F, but you have the definition of G. So for instance, G is the integral of f of t dt. Okay, so here are the basics. If you find G prime, okay, the fundamental theorem of calculus, case 2, says that the derivative and integral cancel out, and you take the upper limit of integration and you put it in. If the chain rule applies, you have to use the chain rule. Here, the upper limit of integration is just x, so this is just f of x. Here, let me write that. Nice and neat here, f of x. Okay, like that. So G prime is f. So if G is the integral of f, G prime is f. And G double prime would be what? G double prime would be f prime. Okay? So stated in another way, if G of x, like in terms of what are these, I'm going to compare it. So see how on this chart I have f, f prime, and f double prime. So if I want to look at it like what's f, f prime, and f double prime. So here, f is G prime, and f prime is G double prime. Okay. So if I want to say it, so over here, I'm going to say if G of x is the integral from 0 to x of f of t dt, if that's the definition, and I would take out your red sheet and write this on it right now. Okay, so if G is the integral from 0 to x of f of t dt, then G prime would equal f. So like this row, that's the derivative, is the derivative, G prime, but that's equal to f, just like regular f. And G double prime would be f prime. Okay? So we can see that these don't line up. So this is like f prime in these problems are G prime, but you don't have the graph of G, you're gonna have the graph of f, and so this is what you're gonna look for f. All right, this, so we just wanna have this down, and then we'll actually do a problem to make some sense of this. All right, a caveat is that G will not always just be the integral of f. It'll always, in these types of problems, it'll always involve an integral of f. But here, if G of x, let's see if it's defined this way. G of x is -3 plus the integral from 0 to x of f of t dt. What is G prime of x? Try to figure it out. Okay, and it is -3 plus, and this is where I use the fundamental theorem of calculus, case 2, where the derivative and integral cancel here, and the upper limit goes in, f of x. But see, you have to use the -3. You can't just ignore that or just leave it the same. You take the derivative of -3x, which is -3. Okay, the second derivative of this, that would be a 0. So this would be f prime of x. Okay, so you do have to pay attention to exactly how G is defined, even though it'll always use an integral. Okay, so here's some basics. So if G is the integral of f, to find G of a number, okay, you're going to find the integral of your graph. How do I find the integral of a graph? Like, how do I actually compute that? I'm looking at a graph, and I say, okay, I want to find its integral. How do I do that? I find the area. Okay. How do I find G prime? Okay, well, G prime is equal to f of x. So if I'm finding G prime, I'm finding f of x. So what is that? It's the y value. If I want to find G double prime, I know that's f prime. So how do I find that from a graph? If I'm looking at f and I'm trying to find f prime, what am I looking for the graph? Slope, right? Okay, here's the notes. This is basically the red chart written in a different way. So this is sort of for reference for you later. If you get a question and you don't know how to do it, instead of looking at an example, you can look at this and do it in read it in words. Okay, so we might refer to this as we take notes, but we'll go on for now, okay? All right, let's do this first example. All right, the figure above shows the graph of the piecewise function f. So I'm gonna label this with a big F, okay? Even though it's already labeled, I highly recommend that annotation, okay? It's like a little long there. Okay, for -4 to 12, the function g is defined as this, okay? So we have g is defined as the integral from 2 to x of f of t dt, okay? So does g have a relative minimum, maximum, neither at x equals 10? So I'm gonna start with g would have a relative min, max, or neither when g prime equals 0 or d and e. And then it would have to change signs in specific ways to get either minimum or maximum or neither, right? But it's just min, max, and neither. You take the first derivative, set equals 0 and d and e. Okay, so but I'm not given g, I'm given f. So what is g prime would be f, the prime, and the derivative cancel out. The upper limit of integration goes in. So f, that would be f of x. So I'm really looking for f of x equals 0 or d and e, and then about sign changes as well. What about the 2? So this is part of the fundamental theorem of calculus, but the lower limit of integration for these problems will always be a number. And so when you integrate, you plug in the x, you plug in the 2. When you derive f of 2, you get 0. So in other words, because the derivative of a number is 0, the lower limit of integration, when you take the derivative of g, does not matter or affect anything because it's always going to be a number and the derivative of number is always 0, so it's always sort of goes away. Okay, so at 10, all right, moving back to the problem. So I'm looking for f of x equals 0. And I like writing it in this way, starting with g and then converting from g to f. Okay, so at 10, is it equal to 0? Yes. So yes, yes. And f goes from, on the left, it's negative, and on the right, it is also negative. So like f is negative, not f prime, just like the y values are negative. It's below the x-axis. F goes from neg to neg, so neither. And again, with these types of problems, I highly recommend that you do the justification first and then you do your answer. Okay, yeah. Okay, let's do B. Does the graph of G have a point of inflection at x equals 4? So am I going to use G? So to figure out a point of inflection, am I going to use G, G prime, or G double prime? I can actually use different ones. Let's see, I'm gonna say, so, yeah, I'm gonna say G prime would have what? So if I'm looking, so if G, let's see, if G, which is here, okay, in this row, has a point of inflection, okay, then what would G prime have? A change from increasing to decreasing, or vice versa, or a local max or min, okay? So G prime, which equals F, okay, has, you can put something in here, just, yeah. You can look at them. Yeah, that's fine. You can get them. Yeah, don't worry about it. Yeah. Okay, so G prime, which is F, either we can say changes from increasing to decreasing or vice versa, or we can say has a relative max or min. Either way. I'm going to write has a relative max or min. Okay? So let's actually see, is that actually true at 10? Does F, which is what I'm looking for, have a relative max or min? Yes. So yes. It does. So G does have a point of inflection because its derivative, which is what I'm looking at, is has a relative max or min. Yes. Yeah. So just like these problems, most of the time you were given a graph of F prime. It was like, here's a graph of F prime, but I'm going to ask you all these questions about F. This is the same thing. You're given a graph of the derivative, but the notation just doesn't have a prime. The derivative is F. And then the regular function that you're being asked about is the integral, which is G. Okay, let us move on to part C and D of this question. And we will have done an entire FRQ. What? Crazy. Okay, so the figure above shows the graph of the piecewise function f. For -4 to 12, the function g is defined the same way. Okay, so I still got this. I'm going to annotate this f, same problem. C, find the absolute minimum value and the absolute maximum value of g on the interval from -4 to 12. Justify your answers. So we know absolute min and max problems are fairly long-ish. So for absolute extrema, we have, this is on the back, we have these candidates where the derivative equals 0 in D and E and the endpoints, okay? And then my test is to make a table, okay? So that's how I do my test. So that's what I'm gonna do. All right, so the absolute min and max. Okay, so G prime, which is F, I want this to equal to 0 in D and E, where? So at -2, 6, x equals -2, x equals 6. Now 10 is totally where it equals 0 in D and E. Here's just like a tip though. So in order to get an absolute max, you need to have either a relative max or an endpoint. Like a relative min is never gonna be an absolute max, for instance. And this is a neither, as we proved in part A. So if this is neither a max or a relative max or a min, it will never be an absolute max or min. So I'm not gonna include 10. Okay, so then I'm gonna do my endpoints, okay, and make a table. So x, and then I just find the y values here. So this I'm gonna do g of x, which is the integral from 2 to x of f of t dt. So the test is to make a table of just with the y values, so x and g. Now I'm going to remind myself what g of x is. I'm just going to write it here, the integral from 2 to x of f of t dt. Okay, so my x values are my endpoints, -4 and 12. And then my relative mins and max, -2 and 6, okay? All right, so, okay, find the absolute min value and the absolute max value. So let me just reread this problem and see what is it asking for. When it says find the absolute min value, is that asking for an x value or a y value? That is asking for a y value. Okay. All right, so let's do this. I'm going to start in the middle. So I'm going to find it at 6. So g of 6 would be the integral from 2 to 6 of f of t dt. Okay, now what is the integral from 2 to 6? So if I start here at 2 and I'm going to 6, the integral is the area of this region. This region is 4 by 4. So it's a triangle, so that means the area is 8. So 8. Cool. And then we'll see if that ends up being, say, the highest, then the absolute max value would be 8. And the justification is doing this workout, of course, right? Okay, let's do 12. So g of 12 is the integral from 2 to 12 of f of t dt. Okay, so let's do 2 to 12. So I'm going to find the area. So this is 8. These two have the same areas, so they're just going to cancel out. It's cool that I know they're 8 and negative 8, but basically they cancel out. I don't even need to know what they are. I just need to know that they're the same. So far from the integral from 2 to 10 is 0. And then from 2 to 12, I add this on, is going to be another negative 4. So this is negative 4. So basically 8, negative 8, and negative 4. All right, so let's do these two. It gets a tiny bit tricky, okay? So g of negative 4 would be, here, I'll zoom in just to be clear. Okay, g of negative 4 would be 2 to negative 4 of f of t dt. Now, let's look at this, okay? This should feel backwards to you. Normally, the lower limit of integration is on the bottom, and the lower number is on the bottom, and the upper number is on the top. Now, is it like illegal or something to have it like this? No, you can totally have it. It just means you're reading right to left, okay? You're reading backwards. However, when we read backwards, it is best to switch it to be negative. So when you switch the limits of integration, you make it the opposite sign. So when you read from right to left, it's like positive. When you read from when you read this way, from left to right, that's positive. When you read from right to left, that's negative. Okay, so I'm going to rewrite this as negative with the lower number on the bottom and put a negative in front. So in summary, when you switch the limits of integration, you put a negative in front. Okay, now I can actually start and read from left to right like usual. So I'm going to put my negative, and then I'm going to like figure out what that is. So negative 4 to 2. Negative 4 all the way to positive 2. Okay, so I can see that these two areas cancel out, and then I get this area, which is 4. So this is 4. So in other words, negative 4 is my output. Oh, I'm tied. All right, let's see. Okay, g of negative 2. Why don't you figure out on your own what g of negative 2 is? You'll probably have to do something like this, okay? Figure out what g of negative 2 is. All right, we're back. So I'm going to sub in. So it's going to be 2 to negative 2 of f of t dt, which is negative 2 to 2 of f of t dt. So negative 2 to 2, okay? This is an area of 8. We figure that out. So this is going to be 8 with a negative in front because I had to reverse the limits of integration. Cool. So the absolute min, this is absolute min. You do need to label it, okay? And this is the absolute max. Do not circle both the negative 2 and the negative 8 because like I or whoever's reading your test will not know whether the min is negative 2 or negative 8. So you say the absolute min is negative 8. If they ask you where it is, like where is the absolute min, you say negative 2, but that's not the answer to this question we're asking, so we're not going to circle it. Okay, part D. Okay, for negative 4 to 12, find all intervals for which g of x is less than or equal to 0. All right, so part D is not always the hardest, but I think in this problem it is. So this actually, let me label this part C. This actually jumps off a lot off of the work we did here. So let's just think about this conceptually. And I'm going to sort of take away the numbers here and just think about areas, okay? So I'm always starting at 2, okay? So if I read right, so left to right is positive, and above the x-axis is positive, okay? So if I go take the integral from 2 to 6, it's going to be positive. If I take the integral from 2 to 8, it's still going to be positive. It'll be less positive because I'll have some positive area and some negative area, but it'll still be positive. Right up until 10, not equal to 10, but right up until 10, yeah? The integral from 2 to just before 10 is still going to be positive because I will be subtracting less area than I've added. Right at 10, the integral is going to be 0 because my upper and lower integrals cancel out. I want the integral to be negative. So from 2 to 10, the integral is 0. And then because this is negative, because this is below the x-axis, it's going to start being negative. Like I'm now adding negative area to 0. So g is going to be negative if I take the integral from 2 to 10.01, you know, all the way from 2 to 12 kind of thing. The integral would be negative, equals negative. So that is one of my answers on the interval from 10 to 12. Okay, let's see if there are any more. It gets trickier because of the reading backwards thing, okay? So now, just gonna clear this out a little bit. So I'm starting again at 2, yeah? So I'm taking the integral backwards, okay? So you might look at this and be like, oh, it's above the x-axis, positive integral. Incorrect, because I'm reading backwards. So this is above the x-axis, but when I go from right to left, I have to switch the sign. So this is actually negative because I'm switching, because I'm going backwards. This is like, in essence, me switching the limits of integration. So this is why the answer to this was -8, right? This is the actual work done out. And then I can actually even see till -4. See, it's still negative to -4. So this is positive, but there's less positive area than negative area. So if I take all this area, which is -8, and I add +4, I'm still going to be negative. Hence, I'm still going to be -4, right? So in this whole interval, the integral is going to be negative. So when you're going backwards, basically above the x-axis is negative and below the x-axis is positive. Again, in summary, when you're reading from right to left, this way, okay, everything is switched. So above the x-axis is negative and below the x-axis is positive. So I also have from -4 until 2. That's my answer. Okay, I'm going to leave it there. Thank you very much. So please be sure you have these items for tomorrow, and I will see you. Bye.